Okay, next topic, talking about ionization energy. Ionization energy is another major factor or another major trend that we see on the periodic table. And what ionization energy really describes is how hard an atom is holding on to its electrons. It's the strength of that nucleus pulling on the electrons. How strong is the pull? Okay, how tightly is it holding on to those electrons? So what it really measures, literally it measures how much energy is used to remove an electron from an atom. Okay. Now, to remember this, what I always remember is that ionization energy begins with the word ion. And we know that ions gain or lose electrons. Okay, it's an atom that has gained or lost electrons. So ionization energy is the energy involved in losing an electron, in removing one. Okay, so if we think back to what we just talked about with atomic radius, we know that if we go down a group, the pull decreases, right? So as we go down, pull decreases, right? And as we go across, the pull increases. Okay, so, and we know that ionization energy is going to be highest when the pull is strongest. Okay, so if we flip this, we know that as we go up, the pull increases, right? And if we put these two together, it means that ionization energy is highest, so i.e. ionization energy is highest at the top right of the periodic table. Okay, it's harder to remove electrons from atoms at the top of a group and to the right of a period. Okay, because their nuclei are not only closer, like the electrons are not only closer to the nucleus because we've gone up, but they also have the most protons, which means lots of positive charge in that nucleus. Now let's practice identifying ionization energy, just like we did radii. Again, the trend is ionization energy is highest at the top right of the periodic table. So it's going to be high here, and it's going to be low down here. Okay? So what I'd like you to do is, looking at these elements, I'd like you to rank them from lowest ionization energy to highest. So go ahead and pause it right now and give that a try. Okay, hopefully you paused it. If you did it just like I did it last time, you went through and you circled. So for instance, copper, aluminum, magnesium, cesium, and helium. Okay, so we want to rank these from lowest ionization energy to highest. Well, the lowest is definitely down here. Okay, so cesium definitely starts our list. Then I have to make a decision between magnesium and copper. To me, we added one proton, okay, and we lost 3 energy levels to get to magnesium, or we could lose 2 energy levels and add, what would that be, about 9 protons. I think in that case, magnesium has slightly less ionization energy. Then I would put copper. If we really wanted to check this, we could look it up online. We could compare the ionization energy of these two, okay, determined in a laboratory. But most definitely after those two, aluminum is next because we're going up and to the right. And then finally helium would have the highest ionization energy. It has 2 electrons. They're super close to the nucleus. The nucleus has 2 protons, so it has a really strong hold. Definitely the smallest. So before we move on to electronegativity, one last thing I want to talk about is how does this factor, meaning how does ionization energy factor into what we know about ions? Well, what it suggests is that elements that are up here in the top right, if we were to use this little staircase shape here and divide the periodic table into a left and a right, elements that are in the top right have high ionization energies, which means they hold tight to their electrons. But anything to the left of the staircase has a low ionization energy, which means that they do not hold tight to their electrons, and in fact, they tend to lose electrons. Okay? They can give them up fairly easily. And that means that if you lose an electron, they tend to form positive ions. Anything to the left of the staircase, basically the metals, okay, they tend to lose electrons, becoming positive ions.